with what I like to call a direct translation word problem. I'm just going to kind of write down as we read it. If you read this problem, it's 1/8 of something plus 1/4 of something. So I'm writing just the denominators down because that's clear that you're going to have something over 8, something over 4 equals to the something, okay? Now in this case, we call that something t because it's the time. Now, again, a lot of this problem is just reading it and labeling everything carefully. It turns out to be convenient to let 0 be noon. That's kind of like shifting things to the origin in geometry, you know, where you put a vertex or you center a circle at the origin, something like that. You know, it makes the math it makes the arithmetic easier. But let's write down what belongs here. Now it says if you add, what does it say here? If you add 1/8 of the time from noon, well, t is the time now, so that would be the time from noon, all right? And so you'll just put a t right here, t over 8. Okay, now what is this next one's kind of a mouthful. If you add 1/8 of the time from noon until now to 1/4 of the time from now until noon, well, how much time is left? Since noon tomorrow is 24 hours, we have to have 24 minus t right here. And that was the toughest part for me. It's not that hard once you just write it down, but that's exactly what the problem says. Okay, and y'all, that's what I mean by direct translation. And I think, I guess, almost, technically, I guess any word problem is amenable to direct translation. But here you write down the equation that describes the circumstances, and you don't have to read the problem anymore. So you see, all we have to do right here is solve for t. Now note, probably the best approach here is just to multiply by 8, right? And if you multiply everything inside by 8, which will wipe out these two denominators on the left, we end up with just t. Okay, that's the point of multiplying by 8 plus. Now, if you multiply this fraction by 8, that means you're going to have to multiply 8 over 4 is 2, so you would have 48. You would have 48 right here. Minus 2t. 48 minus 2t. And again, y'all, I'm multiplying everything inside by 8. All right, and if you hit t with 8, you also get 8t. Not 80, but 8t. All right, there we go. Now, the rest of this is very straightforward. If you add 2t to both sides, if you add 2t to both sides and then subtract 1t, you get 48 is equal to 9t. Okay, now, I'd like to think you can see that both of the coefficients here, both of the constants are divisible by 3. So this would be 16 is equal to 3t. And so we'll just go ahead and write down t is equal to 16 over 3. Now we're assuming this is hours. Well, it is hours, doesn't it? Well, this is how the day works, right? So we have 16 over 3. But notice that's 5 1/3. Okay, that's 5 1/3. And what's 1/3 of an hour? That would be 20 minutes. So this is equal to 5 1/3 hours into the day, past noon. Okay, so 5 1/3 hours, 1/3 of 60 minutes is 20 minutes, right? And so you would get 5:20. And I guess we have to write post-meridian PM. 5:20 is the convention, I think, in the United States and maybe worldwide. But that is a PM, post-meridian, past the middle of the day. Alrighty, folks, that is it. And again, I like the problem because it's a mouthful. Pretty clever professor who would ask a question like that. You know, sure, yeah, how much time are you going to waste? It won't be 5:20 anymore by the time you figure the answer out. But anyway, a direct translation solved this problem.